Today's lesson is on the electron dot model and how to draw it. In this particular lesson, we're going to start off by looking at the Bohr model of the atom, which we learned about earlier in the year. And then we're going to revisit the electron dot model, which we also looked at in the earlier part of the year when we discussed electron configuration. We will then show you how you can draw these electron dot models as a review. And then finally, we'll explain why we use them and what their significance is in the field of chemistry. Now, when we look at the electron dot model versus the Bohr model, we recognize that the Bohr model, first of all, showed all of the electrons that were present in an atom in all of the levels. If you can recall, there were 2 electrons in level 1, 8 electrons in level 2, 18 in level 3. But then the rules got a little bit weird and kind of moved between levels, and the levels kept growing. We don't need to worry about that confusion anymore if we use the electron dot model. The Bohr model also showed all the protons and neutrons in the atom, and in terms of this bonding unit that we're going to be in right now, the protons and neutrons are pretty much irrelevant in bonding, so we're not going to actually need to draw those. The problem with the Bohr model, in addition to showing all this stuff, is that it requires lots and lots of dots for large atoms, so it becomes a real mess and very, very tedious to work with. So we've come up with a simpler way, which is called the electron dot model. And the electron dot model only shows the valence shell electrons, meaning the electrons that are present on the outer level. In this model, we're going to assume that all levels that are not shown are going to be filled underneath. So for example, if I have 7 valence electrons and I have 3 energy levels, we'll assume that there's already a filled first and second energy level with 2 on the first level and 8 electrons on the second level. And that third level of 7 electrons is not quite filled yet. Now, the advantage to doing this is that this means usually you're not going to need to draw more than 8 electrons in order to do this. All right, to show you kind of how the electron dot model works, we're going to move over to Inkscape and use a simulation to do this, and we'll see you on the other side. Okay, here we are back in Inkscape. What you'll notice here is I've created a bunch of little electrons and I've placed them in what I'm calling my valence electron pile. And we're going to use these to actually put these on the atoms in the, that we see over here. Now, to do the electron dot model, it's pretty simple. Really, all you need to do is write the symbol of the element. So, for example, this would be the symbol of sodium or magnesium or nickel, chlorine, oxygen, silver. Okay, what we're going to do here is when you do the electron dot model, you don't worry about protons, you don't worry about neutrons, you don't really even worry about total electrons, only valence electrons, which you should simply be able to find on your periodic table. So all you do is you're going to place the electrons, the electron dots, around the atom based on how many there are. So if we looked up sodium on the periodic table, we would recognize it has 1 valence electron. So I'm going to grab 1 valence electron from my pile, and I'm just going to place it on any of the sides around sodium. And this is my electron dot model. It is saying that I have 1 leftover electron on my outer ring for sodium. Now, when there's only 1, it's pretty easy to do because as long as you place it on any of the 4 sides, either top, bottom, left, or right, it doesn't matter where you place it. You just kind of want to follow like a clock as you go around. Typically, it's easiest to start from the top, though, so that's what I will do in this experiment, or in this activity, I mean, sorry. All right. Our next guy that we have here is magnesium. If we look on the periodic table, magnesium has 2 valence electrons. That means I need to take 2 from my pile. And here's the rule with the electron dot model. It's going to be a little bit different than we did the electron configuration. We're going to place 1 per side first, and then after we've put 1 on each of the 4 sides, if we need to draw any more, we will place them next to the electrons on each of the 4 sides again, and then never go around any more than that. So we would have a maximum of 8 electrons. Now, magnesium only needs 2 electrons, so we've already drawn 1. We only need 1 more. So I grab 1 from the pile, and the rule is that I want to put it on a different side. So I like to go, like I said, in a clockwise fashion. So I'll put my second one here. And this is my electron dot model for magnesium. Magnesium is indicating that I have 2 valence electrons here, just kind of sitting around waiting to do something. All right, we do the same thing for other elements. We have nickel. If we look on our periodic table for nickel, nickel is not in one of those known sections of the periodic table. But if you looked on your periodic table on the right side, it would indicate that it has 2 valence electrons. So we do the same thing as we did with magnesium. It has 1 valence electron, 2 valence electrons. And if you notice here, the electron dot model looks pretty much identical to how magnesium is because it has these 2 electrons that are looking to react with other atoms that have certain numbers of electrons. Okay, but these are our models. So the models are similar, but the symbol here is used to indicate which one we have. So we see magnesium, nickel, similar electron dot models. but they are still different elements. All right, our next guy on the list, we'll look at chlorine. Chlorine, if we look on the periodic table, is in row 7, or column 7, I should say, and that means it has 7 valence electrons. So I simply grab an electron, place it around chlorine. I need 7 though, so I grab a second one, put it on another side. Okay, I've drawn 2. Now I still need to go plenty more, so there's number 3, and that's going to be on yet a third side. Whoops. Okay, I'm going to edit undo that. And then I'll place my 4th on the 4th side. So all the sides now currently have an electron drawn on them, but I still have more space to draw these electrons. So I'm going to grab yet another electron. That's going to be number 5. But because I've already used all the sides, now I'm going to go around again. So now 5 electrons have been drawn. There goes number 6. Okay, and there is number 7. Okay, now that I've drawn 7, what we see here is that chlorine is missing one more electron. We could place one more there. And it just so happens that if you look here, some of these guys have a couple leftover electrons around them, it looks like. So these electrons actually will want to mix up here, but that's in another lesson. All right, so we've drawn the electron dot model for chlorine. All right, we do the same thing for oxygen. We see oxygen is in group 6 on the periodic table. It needs 6 valence electrons. We do the same thing. We place 1 around, 2 around, 3 on the 3rd side, 4 on the 4th side. Okay, all the sides have now gotten an electron, so I still have to place a 5th and a 6th, pairing them up on 2 of the sides. What we see here is now I have 6 valence electrons. This is my electron dot model here. And it's missing 2 electrons, but we don't need to worry about it at this point because that's not what this lesson is about. So we've drawn our electron dot model for oxygen. Our final guy here is silver. Silver is in that middle section of the periodic table also, but if you look for silver on the periodic table, you would see that it only has 1 valence electron, and you would just simply place the 1 dot here. And this 1 dot just indicates that this is its electron dot model. So hopefully you guys have learned a little bit from our lesson. Again, the electron dot models are determined from the periodic table, and all you do is write them around the symbol. All right. Please make sure to copy my notes from my website and be sure to take the online quiz after viewing this, and make sure you bring any questions that you have with you to class.